So hello students, welcome to our YouTube channel. See, that's a question which I got way back as a doubt, okay, and I really found that to be a good question, so I decided to share that question with you people. I believe you would have tried that question. Consider a tetrahedron with faces P1, P2, P3 and P4. So a tetrahedron with 4 faces. Of course, a tetrahedron has 4 faces. Now how do we define a tetrahedron? So like that's the vertex of the tetrahedron, one side, two side and third side, okay, and on the in base you have a triangle. So it's like you form a triangle. So if I form a triangle here, so if that's the triangle here, okay, and this is the vertex, so you join this vertex with all the 3 vertices of the triangle, that's your tetrahedron. So of course it has 4 faces. One is the base, and then one face is like this one, one face is this one, this side, and the other face is this side, bachcho, okay. So now let vector a1, vector a2, vector a3 and vector a4 be the vectors whose magnitudes are respectively equal to the areas of, so it should be areas of, okay, so here it should be areas of the faces P1, P2, P3 and P4, okay. So vector a1, vector a2, their magnitude represent the areas of these faces. So if I say that this is vertex O, if I call it to be vertex A, B and C that form the base of the tetrahedron, and here I put it the vertex O. So a triangle OBC, that's one face, let's say it's P1. Triangle OAC is second face, that is P2. Triangle OAB is the third face, which is P3, and base of course will be the fourth face, okay. Now area of this triangular face P1 is represented by the magnitude of, let's say, vector A1. Similarly, area of this face of the triangle like OAC P2 is represented by the magnitude of vector A2. Likewise for the third one, and likewise for the base, this triangle ABC, its area is represented by the magnitude of vector A4. So that's what we are assuming, whose directions are perpendicular to the faces. Okay, the vectors, I mean, see, magnitude gives you the area of the face and the direction of the vector is perpendicular to the face, okay, and outward direction. So what does that mean? See, okay, if I consider this to be the vertex O, so O, B, C, so that's the outward direction. So for this will be the outward direction, okay. Outward means out of the tetrahedron. So for this face, the behind the board will be the outward direction because its vertex is on this side, our side of the board, okay. So now we have to find the value of magnitude of vector A1 plus A2 plus A3 and A4. So now for that sake, I will assume that the vertex to be O, that is outside on our side of the board. So here is somewhere we have the vertex, okay. Now OA, I am defining the position vector of vertex A, the base is as vector, let's say, what shall I do, PQ, okay, let's take it as vector P, B for vector Q and C for vector R. So okay, so this is vector P, OB, position vector of vertex B with respect to the vertex of the tetrahedron O is vector Q, and vector OC is vector R. That's it, okay. Now if I ask you people to find area of triangle OBC, so we all know it's nothing but half times the cross product of 2 adjacent sides, okay, in terms of the vector. So now we have to be careful because we need the vector form also. Magnitude is fine, OB cross OC is okay, but then we have to see that if this is our origin, the vertex of the tetrahedron, then OB cross OC. So I am putting my right hand finger like this. So how shall I do it? Just a minute, bachcho. Okay, so if that is the vertex OB cross OC, right hand thumb rule. So I am putting my finger in terms of the direction of OB and curl, moving it in the direction of C. So the thumb is outside the tetrahedron, outside the base, okay. So that means the direction wise is perfect. So area wise, magnitude wise, is of course this is the magnitude, okay. So this is magnitude of vector A1, But vector A1 is how much? So vector A1, because it comes with the direction. Okay, so I won't be putting magnitude in that case. So it will be then vector OB cross vector OC, and while writing it, we have ensured that the direction is towards the like outside the plane of that tetrahedron. So how much is it? So it's half B cross C, rather it's P, rather OB is Q, if I'm not wrong, Q cross R, isn't that? So Q cross vector R. So that's first one. Now let's come back again to this figure, because see, we have to ensure that direction. Okay, now this is the vertex here, so OC and OA, that's the plane. Okay, so for outward direction, so what are we going to do? So OC OA, so it will be OC cross OA, and then it's outside the plane, OC cross OA. Okay, so the second one, A2, will be half OC cross OA. So how much is it? So it's half R cross P, isn't that? Achha, we are moving in the cyclic order, isn't that? So now for the last one, OAB, so again OA cross OB. Okay, again you look at it, this is the origin, OA and OB. So OA cross OB, so it will be it's in the outward direction. So this is A3, half OA cross OB. So how much is it? Half OA is P vector cross Q vector. That's it. So A1 plus A2 vector plus A3 vector will be sum of them. Now the point is for A4. A4 is the area vector for the base, and we need it outside the plane. And now see, for us, since the vertex of the tetrahedron is on our side of the plane, so the outside the plane will be on the back side of this board. Okay, so how do we do it? So in that case, I think it will be AB cross, if I put it as AB cross AC, it's inside. So we have to do it as AC cross AB, isn't that bacho? AC cross AB. So let's do it. So I will write it as half times AC cross AB. Okay, so therefore, now that's what hold the key, I believe, half times AC. AC is vector R, vector position vector of vertex C minus position vector of A. So minus P cross, and then it's AB. AB is Q minus P vector. Isn't that bacho? So now let's do it. So what will we get? Half times R cross Q minus P cross Q minus R cross P, and minus P cross P we all know is 0. Now if we add all, so vector A1 plus vector A2 plus vector A3 plus vector A4, so how much is it? So if I take half common, put the value Q cross R, so it's Q cross R plus R cross P plus P cross Q minus plus R cross P. So see, R cross Q and Q cross R. So I can reverse its position by taking minus sign. So Q cross R minus P cross Q, we got it, minus R cross P. So everything gets cancelled. So isn't that interesting question? Okay, so this is nothing but null vector. So magnitude is nothing but 0 bacho, and that's the answer. So that's why I said I found it to be an interesting question, a different form of a different type of question based on the use of algebra, vector algebra in geometry. See, that's one thing on which I am insisting again and again in my questions of vector algebra here. It's used in the geometrical figure, okay, whether it's a planar figure or it's a 3D figure bacho. So that's it. So that was the question for today bacho.